All right, guys, welcome back to statistics. We're going to be talking about some different confidence intervals again today. We're going to be taking a question out of the packet. We're going to be doing a little bit different stuff with it, but just a scenario that it provides. So we're going to take a look at 38. First USA, a major credit card company, is planning a new offer for their current card holders. The offer will give double airline miles on purchases for the next 6 months if the cardholder goes online and registers for the offer. To test the effectiveness of the campaign, First USA recently sent out offers to a random sample of 50,000 cardholders. Of those, 1,184 registered. Okay, so here's what we want to do. The number of people that they sent this out to is 50,000. The number of people that registered was 1,184, I believe. I'm going to double check my numbers, but yeah. So that means how many people didn't register? Well, quite a few, right? If only 1,184 did, then the rest of the 50,000 didn't. That is 48,816. Now, of course, we want to find the decimal version of our proportions here. So we are going to take the number that did this out of the whole. So 1184 divided by 50,000 and gets 0.024 when we round it. And the opposite of that number will be our Q, which is 0.976. Okay. We're going to go ahead and find the standard deviation. We know our mean, our average, 0.024. But let's find our standard deviation. To find the standard deviation, P times Q over N, otherwise known as 0.024 times 0.976 over 50,000. It's a lot of trials, so should theoretically be a pretty small standard deviation. But let's find out. 0.024 times 0.976 divided by 50,000. Yeah, we get a real small number. We get a standard deviation of 0.0007. Very small, right? Now what we are going to do with this information, what we're going to do with this data, is we are going to find a 95% confidence interval. We are going to find an 80% confidence interval, and we're going to find a 40% confidence interval. Here's what I'm going to do with this number. I'm going to, since these both only have 3 digits, I'm going to round this to a 3-digit number as well. So I'm going to let that 7 round it to just 0.001. All right. So the 95th confidence interval says that we are going to go 2 standard deviations. We know that right off the bat. That's just something that's just the way it is. 2 standard deviations above, 2 standard deviations below the current proportion. So that would mean we have 0.024 plus 2 of these, plus 0.02, right? So that would be 0.026. And then we want to subtract 2 of them from the 95%. So that would be 0.022. That's the 95%. Otherwise known as 2.2% to 2.6%. Pretty small range still. even being 95% confidence interval. But let's see how big the confidence interval is for our other ones. With an 80% confidence interval, we have to take an additional step in the work. We need to figure out what are the boundaries for our percentiles, right? So if we want the central 80% of data, with of course the center of the data being 50%, we want 80%. That means how much is going to be on either side of the 50? That's right, 40. I have 40 above, 40 below. Well, 40% above 50 is 90%. 40% below 50 is 10%. So we are going to be looking for the z-score of 10% or 90% to figure out how many standard deviations away it is. Now I always like to just look at the upper one. That's what I do. So the 90% z-score. I'm looking here, and the one I see that is the closest to it is 1.28. So we get a z-score here of 1.28, meaning that to get an 80% confidence interval, we need to go 1.28 standard deviations above and 1.28 standard deviations below. Now to just work out the math here, what I'm going to do personally is I'll do 0.024 plus 1.28, the standard deviation amount, times the actual standard deviation, 0.001. And then I'll do 0.024 minus 1.28 times 0.001. So let's see what we get. 0.024 plus this number. We get 0.02528. And we get minus this 0.02272. So this is our 80% confidence interval. If we can, turn this to percentages, we get about 2.3% up to 2.5%. So we're a little bit smaller range now. Let's see what the 40% does. One more time, we're going to have to figure this out. We only want the central 40% of the data. So with the center at 50, and we're going central 40, that means we're going to have 20 above, 20 below. That's going to go from 30 to 70. I'm going to look up the 70th percentile. And I'm going to find the 70th percentile to be at 0.52. That looks like the closest one to me. So I need 0.52 standard deviations above and 0.52 standard deviations below. So I'm going to do the same math, but instead of 1.28, I only need 0.52 standard deviations above and 0.52 standard deviations below. So let's see. That's going to be, on the upper side, 0.2452, and on the lower side, we are going to get 0.234. So, if we were to round this, it'd be, I forgot zeros in front of these, my bad. If we were to round this, we would get 2.3 to 2.5, exactly like what we had up here. However, if we were being more specific with our decimals, like let's be honest, we probably should be, then what would we be seeing? we have 2.34% to 2.45%. If we were to go out one more decimal on these, we're really looking at 2.27 all the way to 2.52. So we see that we're even getting a little smaller with our range, right? 2.27 up to 2.34, 52 is down to 45. We're getting a lot smaller. Again, it's important to think about the success rate and the fail rate with these. A 95% confidence interval means 95% chance we're right, 5% chance we're wrong. 80% chance we're right, 20% chance we're wrong. But right here, that is only a 40% chance we're right, 60% we're wrong. Should we ever use a confidence interval this low? Probably not. If you have any questions about this, no book work today or packet work today, but if you have any questions about this, let me know. I'll be more than happy to help. Otherwise, see you guys next week.